Welcome to fennaelearning. In this project, we are going to see automatic handwriting recognition system for person identification. The objective of the project is to design an automatic system to recognize the handwriting of a person in biometric applications. Gauber filter is used to extract the texture features from the handwriting images. And Naive Bayes Classifier is used to identify the person based on the extracted features. Literature survey. So in the first paper, convolutional neural network is used for handwriting classifications. Gradient based learning approaches is used for training the convolutional neural network. The limitation of this work is the error in the training the classifiers is quite large. In the second paper, long-term short-term memory networks is used for segmentations of characters. CNN is used for classification. The major limitation of this work is the model did not perform better because of imperfections in the segmentation model. In the third paper, multiple fine-tuning approaches is used. Ensembles of multiple fine-tuned convolutional neural network is used for classification. The limitations are complex networks architectures are used. System provides poor results for large database. So this is the flowchart of the proposed method. So we have to give handwriting images as input image, and we have to pre-process the image to obtain more information from the input image. Then Gauber filter based features are extracted from the input image, and Bayes classifier is trained for classification of the handwriting based on the person. So this is the sample images from the database. So normally 25 persons handwritings are stored in the database. Each person have 20 images. So this is person 1 handwriting image, and this is person 2 handwriting image, and this is person 3, and this is person 4 handwriting images. Pre-processing. So pre-processing is necessary to enhance the image and to remove unwanted distortions present in the images. The steps involved in pre-processing are locate text lines, identify the number of text lines, and separation of each text lines. So these are the major steps involved in the pre-processing. In the first step, we have to obtain the histogram of the image. After obtaining the histogram, we have to generate the vertical profile of the image. After generating the vertical profile of the image, we have to calculate the centroid of the images, and then binary scale of the image is used for thresholding, and segment the lines of the image using centroid points. So this is the output of the pre-processing step. So this is the input image, and this is the pre-processed output image, and this is the intensity projection of the image. This graph gives information about the intensity profile of the handwriting images. The higher intensity profile indicates the number of lines in the handwriting images. This indicates 1 line. This higher intensity value indicates 1 line. This indicates 1 line. Based on this intensity projection of the image, we can calculate the number of lines in the handwriting images. Then feature extraction process. The Gauber filters is used to extract the features. The Gauber filters with different frequencies and with orientations in different direction have been used to localize and extract text regions only from complex document images. The impulse response of these filters is obtained by multiplying a Gaussian envelope function with the input data. So different scales and different orientation of the images are analyzed by using this Gauber filtering technique. So this is the Gauber filter function. So we have this even and odd symmetrical Gauber filter function that is expressed as h(e) of x comma y and h(o) of x comma y. And here g of x comma y is the Gaussian function, and this cos 2 phi of x cos theta plus y sin theta is the basis function. And the Gaussian function is represented by g of x comma y is equal to 1 divided by 2 phi sigma square exponential of minus s square plus y square divided by 2 sigma square. and here f represents the frequency and theta represents the spatial orientation and sigma represents the constant, space constant of the Gauber envelope. Using this function we can analyze the image in different orientation and different frequency. So this is the Gauber filter output, and the diagram shows the magnitude of Gauber filters. Using this magnitude function we have to analyze the handwriting images in different scales and orientations. And this is the real part of the Gauber filter function. Naive Bayes classifier is used to perform the classification task. This classification is widely used for text classifications, and it is a supervised based learning method, and this classifier easy and effective classification method that aids in development of fast machine learning models capable of making quiet predictions. It is a probabilistic classifier, which means it makes the prediction based on an object's probability. The Bayesian classifier is based on Bayes' law, which is used to determine the probability of a hypothesis with prior knowledge. And this classifier depends on conditional probability. So mathematically, Bayes' theorem is stated as P of A given B is equal to P of B given A into P of A divided by P of B. In this algorithm, we are trying to find the probability of event A given the event B is true, and event B is considered as evidence. And here P of A given B is called posterior probability, and P of B given A is called likelihood probability, and P of A is called prior probability, and P of B is called marginal probability, and P of B is also called as probability of evidence. And the major steps in Bayesian classifiers are: in the first step, we have to convert the extracted feature set into a frequency table. In the second step, a likelihood table is determined by finding the probabilities of given features. In the final step, we have to use Bayes' theorem to calculate the posterior probability. The posterior probability P of A given B gives the final results. And this is the final graphical user interface model of the project. And here we have the push buttons to load the image and for pre-processing, and to design the Gauber filter, feature extraction and Bayesian classifier. And the performance of this work is analyzed in terms of accuracy, sensitivity and specificity. And the accuracy parameter is defined as the ratio of correctly detected images in our database to the total number of images in our database. And these are the reference paper related to the project. Thank you for watching this project video. Kindly subscribe, share and support the work. Thank you.